Hello, this is Antonio Mallarino. Most likely, most of you have heard me speaking about micronutrients before, but I decided to put together some research that we've done, over the years. There's nothing new over the last 2, 3 years, but I'm showing it in a little bit different format because there is lots of interest out there in terms of if we should apply micronutrients, we should not, how do you know if we need the micros or not? Micronutrients are essential nutrients, but the main difference with other nutrients like macronutrients, nitrogen, phosphorus, potassium, or secondary nutrients like sulfur, calcium, magnesium, is that they are needed in very, very small amounts. At this time, there is general agreement in that the micronutrients essential for crops are those that are listed there: boron, cobalt, copper, chloride, iron, manganese, molybdenum, nickel, and zinc. There are some arguments with nickel, but because apparently they are needed by the rhizobia, in the nodules of legumes, but and cobalt too. But in general, those are the ones that are essential. Doesn't mean that we have deficiencies of all of those in Iowa. The other thing interesting about the micros is there is a very large variations in the crop sensitivity to different micros. And then, of course, the question is fertilization needed? Well, not necessarily if the soil supply sufficient amounts, which, by the way, is the case for most of Iowa. Here I put together some of the amounts removed with corn grain. Okay, we have the removal of boron, copper, manganese, and zinc, and according to the yield level. Okay, the one that is removed the most is zinc, but even then you see that it's about less than half a pound. Most of the others is really, really small. Now, I show this so you have an idea how the amount in grain removed compares with some of the other nutrients, not because you should apply micros based on removal. Do not apply micronutrient based on removal. It doesn't work like for P and K and doesn't pay. There is agreement all over the north central region about this. This slide shows soybean now. Again, very small amounts, a quarter of a pound or less for most of these nutrients. I show these because are the ones we work in a very large project a few years. Again, just to show you the small amounts removed, not that you should get the idea that you should apply micronutrient based on removal. It doesn't work. Now, we have lots of manure being applied in Iowa. Many, many fields have manure application, and the probability that we can get a deficiency of micronutrients where manure is applied is very, very, very rare, very small. Okay, I put there some data from Iowa. I included sulfur. Sulfur is not a micronutrient; it's a secondary nutrient. Just for you to have an idea, manure applies sulfur, iron, manganese, boron, zinc. So if you have manure soils, okay, the likelihood of having a micronutrient deficiency is essentially zero. Now, this chart was put together by some fertility people back 30, 40 years ago, and is somewhere in the extension publications of all the universities in the north central region. It's a good idea, approximate and general, to give you an idea when a micronutrient could be deficient or maybe needed. So we have there listed boron, copper, chloride, iron, manganese, zinc, and molybdenum. Then there is two columns. One is the soil conditions in which they could be needed. So we have sandy or highly weathered soils, very low organic matter, drought. I have not seen that here with boron and drought, probably because we have lots of boron, in Iowa soils. Copper in acidic, organic, sandy soils, calcareous soils. Chloride, sandy, highly weathered. Iron, very calcareous or very sandy soils. Manganese, organic soils of pH higher than 5.8. Some calcareous soils, sandy soils, and soil saturated with poor aeration. And then zinc can be deficient in sandy soils, highly organic soils, calcareous soil, and extremely high in phosphorus. Okay. But I tell you, I'm not showing data about that, but we have not seen this in Iowa, even in fields that have very high P for fertilizer and manure. We have not seen an induced zinc deficiency due to high phosphorus. And then molybdenum in very acidic soils or very sandy. Now, then in terms of the crop, you can see there, for boron, we have alfalfa, clovers, canola, sugar beet, copper, wheat, oats, corn. The most important is wheat. Wheat, triticale, all those, especially in the Great Plains, sometimes they have a deficiency. Chloride, wheat, potatoes, not much of those in Iowa. Iron, soybean. You are very familiar with iron chlorosis in soybean in some soils of north central Iowa on extreme western Iowa. Manganese, soybean too, wheat, oats, sugar beets. Now, it's interesting that experienced people like Bob Heft, some of you may remember, in Illinois and from Indiana, all they were telling me, if you see a deficiency that looks like iron or manganese, west of the Mississippi River is iron. If it is east of the Mississippi River, that may be manganese. Okay. Then zinc in corn and sorghum. Those are the two crops that is most often seen. And then molybdenum is especially in legumes like alfalfa, soybean, but it has to be extremely acid soil. That you can tell there that no farmer should have a soil less than pH 5.5. So the best thing for molybdenum is to be sure that you lime the soil. So you don't need to apply molybdenum. Now, we have problems with the diagnosis of deficiencies for micronutrients, okay? The deficiencies in Iowa and neighboring states are infrequent, except for iron in soybean grown in highly calcareous soils. You are familiar with that. There is very difficult soil or tissue testing calibration research. That is scarce responses, infrequent. And then there are many micros to be evaluated. So it's very expensive to go and search for deficiencies, especially when we don't have a good soil testing that we really can trust for the micronutrients. Soil testing for micronutrients has been much less reliable and useful than for pK or pH, by far. Then, tissue testing for microbes hasn't been more reliable either. Okay. In addition to that, testing, can we do the testing early enough so we are able to correct a deficiency for the current crop? Seldom is the case. There is little or no test calibration work because we don't find responses out there. And then many people out there that have these sufficiency levels for micronutrients, especially private companies, they come from available concentrations for just fields that just are good looking. They are not trials. They have not measured yields. Essentially, they look, okay, what is a great looking soybean field, for example, and then they measure those concentrations. But that doesn't give an index, because it could be an excess. That doesn't mean that you need all that high in there. So we have issues. Now, we have many micronutrient fertilizer sources, and I don't want to go too many details because really, most of these we don't need it in Iowa. But essentially, for boron, we have sodium tetraborate, borax, or pentaborate, or boric acid. For copper, iron, manganese, molybdenum, and zinc, we have inorganic oxides and sulfates. We have various chelates, that is organic compounds that retain in a very weak way some of the micronutrients. The most common are EDTA, EDDHA. And then in some regions, there are available organic complexes, from the paper, citrus, or sugar industry byproducts, that they supply micronutrients. So in terms of deciding about this, it's not easy, but the important thing is the solubility of the mineral sources. For example, in general, the oxides are less soluble in water or in the soil than the sulfates. And then the chelates, which are good, especially, for example, iron chelates, in general are better for soil application in calcareous soils because they are less retained than the fertilizers. Now, the application methods. Again, all over the north central region, there are not too good data about the application because the same reason I said before, there are no frequent deficiencies. So we cannot really have much faith in some of the data we have. Most sources can be applied to the foliage or to the soil, okay? But there are some rule of thumb. Iron. Iron is better, normally the iron deficiencies, not for corn, but for soybean. Sometimes alfalfa is better to be applied foliar or banded with the seed, okay? Because when it is one of the situations, it can be deficient, is in highly calcareous soils. Then this way is less retained by the soil. It's more available for the plants. Boron, the main thing is that you should not apply with soybean seed. Okay, boron is very easy to become toxic. Most of the research in Minnesota, for example, with boron, is the excesses. See, there is toxicity from boron. Here in Iowa, we have not seen toxic levels yet. The molybdenum, if you decide to apply, it's better to apply with the seed or in furrow. But remember what I said. The best things to avoid molybdenum deficiencies for legumes is to lime. You should not have pH below 5.4 or 5.5. See, if you lime, then that's okay. And then the chelates are less retained by the soils. So soils that are calcareous, that have very high fine texture, for example, the chelates may work better than some of the others, but often, especially with the sulfates, there is not much difference. And then, because of the things I said, broadcast rates sometimes need to be higher than for banded or foliar application. Now, in Iowa, there has been lots of research on micronutrient for corn and also soybean. I just put some here very briefly. In the 70s and 80s, John Webb, he retired in the early 90s, passed away now. He had 4 long-term trials. He had continuous corn and he put broadcast zinc with two sources, and then he found isolated responses only when the soil test for zinc by the DTPA method was less than 0.9 ppm. Okay. Then I analyzed another long-term trial that John Webb established in 1965 when I was here as a postdoc in 1991. I summarized. This was a long-term trial in the Kanawha research farms that we have zinc broadcast and several phosphorus treatments. The phosphorus treatments, this was published, and it is the highest rate. I think all those years applied like 5,000 pounds of phosphorus, P2O5, something like that. And not even at those extremely high rates, we show no yield increase, but the DTPA zinc was about 1 ppm or higher. So then that's what I said. You should not trust too much when people talk about that interaction phosphorus zinc. We have not observed here in Iowa, even with very high phosphorus levels. Then Randy Quilon, his student Bickel, had 12 strip trials from 1998 to 2000. He used to apply planted band zinc, and then they measured yields along the strips. They have 61 comparisons, with zinc or no zinc for corn, yeah, and there were 2 increases and 7 decreases, and they concluded that the soil test wasn't trustworthy, the DTPA that they used. And then when I came here early in my career, we have these questions about chloride. So we have some trials in research farms where they have not been receiving any potassium chloride application for 30 years. So I modify a few plots in 2 sites to see if there could be some response to chloride, okay? And we just saw a very small response to chloride, but as I said, no potash had been applied for 30 years, so it makes sense. Most people use potash there, so they are applying chloride. So based on that research and actually borrowing from neighboring states, here in Iowa State, we have had recommendation of zinc for corn and sorghum, and until last year was only by the DTPA test. Okay, in the revision that we did in February of this year, we added the MELIC3 test. Okay, we did not see much response, but the correlations with the DTPA are kind of good. I will show that. And because many labs out there, they don't like the DTPA and they love the MELIC3, so they are doing it. So we decided to include interpretation for the MELIC3 here. So these are the current interpretation for zinc that we have in Iowa. For the DTPA, these are the old ones that we used to have for the last 40, 50 years, and the MELIC3 are the new ones that we introduced last winter. And then these are the rates, okay? And this is that all my senior fertility peers decided years ago. 10 pounds broadcast for low, 5 pounds broadcast for marginal, and then if it is banded, 2 pounds for low and 1 for marginal. This is what most states recommend. Honestly, I have not seen any response, so I cannot really confirm with my research after many years these recommendations, but it should be safe. Let's put it that way. Now, soybean. In Iowa, there was lots of research in the 60s by Muy. He was a professor here in agronomy, and he had many trials. He applied 6 micronutrients, different rates, and they saw a yield increase only from molybdenum in soybean when the pH was actually less than 5. Okay, so this is the only positive response that we have in Iowa. But as I said, who's going to have pH 5 or less? You should not. You should lime. So then molybdenum is not a problem. Then with my student, Masar Hack, actually Masar was my first student or second student. We did several trials. We did 18 field trials in farmer fields that we have an NPK sulfur mixture with or without salt boron, with or without iron, or with or without zinc. Okay, these were foliar fertilizer trials, and we see no yield increase at all at any site. Paul Castle, who had one trial in northern Iowa, he sprayed 5 different products with manganese and other micros for soybean, no yield increase at all. Fred Blackmer, in 2005, and his students, they have 4 trials, and they sprayed 2 iron products to fill areas that were chlorotic. Okay, so they were highly calcareous soils. There were obvious iron deficiencies when the plants were small. They sprayed, but they saw no yield increase. They saw a bit of green up in some of the fields, but no yield increase. So then finally, from 2005 to 2008, I did the same trials that I did with corn in those long-term experiments that had no potash for 30 years, so no chloride for 30 years, and there was absolutely no response to chloride. So more recently, Brian Lang was a field agronomist in Northeast Iowa. He retired about 2-3 years ago, and he had an experiment with for manganese. See what I'm showing here, the photo on the right, that comes from Indiana. He didn't take photos or didn't share with me. That's what they call the magnesium, the manganese flash. Okay, it's looks yellow, but actually it's more it's a whitish color. See, I don't know why that it's kind of yellow in the photo. So they have Brian has 3 experiments in 2008, 2009, 2010. Okay, so he put just glyphosate. Okay, and there were no difference. Major difference in the yield between the years. Just 2010 was a bit higher, the yield. Then they have a glyphosate tank mix with manganese. Then they have glyphosate plus manganese sprayed 15 days later. And then they have FlexStar Fusion plus manganese 15 days later. They apply about 0.3 pounds of manganese per acre. So they show a response, okay, only in 1 year, 2008, when the glyphosate plus the manganese sprayed 15 days later, the yield was a bit higher than glyphosate alone or a tank mix. Okay, in Indiana, the deficiencies of manganese are very common. The soils are completely different. And this is where really, especially the excess glyphosate, higher rates, then they have induced manganese deficiency in Indiana. We have not seen this in Iowa. Some people told me that sometimes when there is a overlap in the application of glyphosate, they have seen a bit of the the manganese flash, the white things. But research in Minnesota, Wisconsin, Illinois, and Iowa and Missouri have not seen really any problem. So in Indiana, yes, because manganese has been always kind of limiting there in those soils. Then Mark Licht, he's a professor here, but I believe when he was a field extension agronomist, he had two trials in 2011, 2012, and he tried, soybean with all these treatments: control, glyphosate, manganese, zinc, glyphosate plus the manganese, glyphosate plus zinc, glyphosate plus manganese plus zinc. He got absolutely no difference, no yield differences. So when I in 2011, 2010, people started, there was a surge of interest about micronutrients. So nobody else wanted to do this research in the agronomy department. John Sawyer didn't want to. Before him, Randy Quilon didn't want to. Okay, so here goes Antonio, So I tried. It took me 1.5 years to put a consortium together of companies, several companies, the Iowa Soybean Association. You can see there all the companies that were involved. And then with some farmers and Iowa State Extension agronomists, we put together a large research project with micronutrients beginning in 2012. So some of the projects involve foliar spray, foliar feeding, okay? So we have plot trials, okay, at farmers' fields and research farms replicated. So we have 46 soybean trials, about 35 or 37 of those on farmer fields, and 10 corn trials. The corn trials were at research farms. And those that worked with these were mainly my student, Josh Anderson, Master Hack, and then also research associate Louis Thompson worked with those. So what we decided to do was to test boron, copper, manganese, and zinc, okay, and the mixtures with four replications, okay. We sprayed this after many meetings, mainly with the companies. We agree at the rates and at the products that we're going to use, okay. So we sprayed at V5, V6, and then again at V8, V10 in corn, or R2, R3 in soybean. We decided for rates they were not excessive, and we decided to apply twice, just to be sure that if there was a efficiency, we were going to get a response, okay? So we used boric acid, Maxine, with all these sources that are listed there. But then we wanted to have some more trials. We decided to work with the superintendents of research farms and several field agronomists. And they have 26 strip trials at farmer fields. We have all over Iowa. We have 17 strip trials with soybean replicated, but just with or without, okay? And 9 corn trials. So, and we decided in all of them to apply the same rate, the same product. It was a mixture of boron, manganese, and zinc, one application only at the V6 to V8 stage. This was a very, very large project, and those are the rates that we apply. Then we have another project that was micronutrients applied to the soil, okay? This was mainly funded by Pioneer, Cortiva now, but some of those companies also help with funding or products. So we have 8 trials, 3 years each, with corn soybean rotations. We started 4 of those with corn, okay, and 4 with soybean. And there was a bunch of people working here: Master Hack, Pablo Barbieri, a postdoc, and then Louis Thompson, research associate. And also because these were in research farms, we have a tremendous help from the superintendents of these farms. So we decided that the treatment would be boron, manganese, zinc, applied with the planter and with MAP. At the time, some people were saying that the response to micronutrients with the planter could be more frequent if were applied together with MAP. I doubted it, but I just wanted to give the chance of measuring, the best response that we can get. And then we have a mixture, okay, band or broadcast with MAP too. So we use the solid granulated fertilizers. For boron, we use new boric acid that also have a very small amount of sulfur. And banded, we put 0.5 pound, and broadcast, we put 2 pounds, okay? And the manganese, we use Brodmann 20 that had about 12% sulfur, and we applied it at about 5 pounds of manganese per acre. And then zinc, we use EZ20 that has some 14% sulfur. We applied at 5 pounds of zinc per acre. This is the problem that I mentioned before with micros research. It is seldom you can have only one micro there. You have some other treatments that you're applying at the same time. Okay, these are the location of the trials. On the left, we have all these trials that we did at farmer fields and at research farms. The red star is soybean and the blue star is corn, foliar feeding, okay? And then in the map of the right are the 8 research farms where we did these 3-year trials with application to the soil, okay? You may look there, that blue star in the extreme right, that's a sandy soil. We had one trial and the Muscatine farm, there in extreme eastern Iowa. Okay, I'm not going to be able to describe all the soils. This is what we had before. These are ranges across all 106 trials, okay? pH was 4.9 to 7.4, organic matter 2.5 to 8, the clay percent was 9 to 34. 9 was that sandy soil, but it wasn't extremely sandy. And then we have the CEC was anywhere from 13 to 37. These are common in Iowa, except for those low values of the sandy soil. Now, the grain yield results. I will not show the results because essentially they were not any. Okay, in the 56 foliar fertilization trials conducted in plots, remember, in farmer fields or research farms, there was no grain yield increase at any trial from anything. Okay, mixtures, single nutrients, nothing. But at one trial, there was a yield decrease from copper, zinc, and the mixture. I don't understand why. Most likely that was a statistical fluke, because I don't see why there would be a yield decrease of soybean with copper alone, zinc alone, or the mixture. Then in the 26 foliar fertilization strip trials, those simple trials, long strips across fields, there was one soybean yield increase and one corn yield decrease. That's what we found. And we could not really explain the yield decrease or the yield increase given the soil samples that we took and the plant analysis that we did. So I believe they were, again, statistical flukes. Then in all these 3-year trials at 8 fields, okay, we saw absolutely no yield increase or decrease. By the way, I forgot to say that we reapply these treatments every year in those 3 years, okay? And for you to have an idea of the yield levels, with soybean were 20 to 74, Now, that 20 or the lowest yield was because mainly 2012, if you remember, there was a drought. And then corn went from 144 to 255 bushels per acre, the average 200, and that the low 144 was in 2012 when we have that drought, but we saw absolutely no yield response. We did see some increases in the foliage trials mainly. We saw some increases on the micronutrients in soybean grain. Okay, so that means that what we applied at least got into the plant. So we have here the relative concentration, of in soybean grain percent. We have bottom. There was a difference between the 2012 sites and the 2013 and 2014 sites, copper 2, and manganese and zinc. So we kind of saw a difference, saw a response in the micronutrients content in the foliar trials in grain, but no yield response. Okay, I decided not to work with iron because of all those trials that I mentioned before with soybean or corn. There have been no success with iron fertilization in Iowa. And even in all the north central states, including calcareous soils, my colleagues were not, since the 60s, were not recommending iron fertilization because most of the times didn't work. But what happened? About 6-7 years ago, there was a product that used to be very expensive, okay, but then became cheaper, which is a chelate. It's called OOEDDHA chelate, okay? So my friends from Minnesota, Dan Kaiser, and then Dorival Ruiz-Diaz in Kansas, they started working on that. See, when I was starting this, they were working on it. They said, okay, you guys work. I could not get funding to do these similar trials here in Iowa. One company offered me funding, but it was just for one trial. Of course, I'm not going to waste my time in just one trial. So on the left, we have what they found. There was a highly calcareous soil. You can see in the photo there in Kansas. And there was a significant response to this OOEDDHA chelate. See, there are several other chelates. This was this new one that they use. And there was an interesting response, okay? But even in the best of the situation, the yield was about 30 bushels per acre. So, yeah, seems that it could be promising, but, the best thing to do in these calcareous soils is to use a soybean variety tolerant to iron chlorosis or just plant corn, really. Then on the right is the data that Dan Kaiser had in Minnesota with the same type of chelate, okay? And I just took this graph from a presentation he gave at the ICM conference a few days ago here in Iowa. And what he had iron deficiency chlorosis resistant or susceptible varieties, okay? So he applied for all these varieties, these rates that are there, okay? And he found response only those bars on the right, extreme right, where there was a very severe iron deficiency chlorosis, very severe, when there was no or low IDC, no response, when there was moderate, not significant response, and then, but when there was severe, he found a response. So this coincides with the data that Dorival found in Kansas, also in calcareous soils. So I believe that if somebody wants to, here in Iowa, they could try some of these. It has to be either in the seed or in furrow, okay? because apparently there is a potential. The problem that we have is that in Iowa, no field is all calcareous. You see, we have these spots, small, high. So you could try, but as this data show, in Minnesota, the yields were a bit higher, about 40, 42 bushels. But still, I don't think that this product is magic, seems better than the others, may increase yield a bit, but in my opinion, the best things to do is to use a tolerant, a soybean variety tolerant to iron, or just, if the majority of the field is calcareous, plant corn, really. Of course, you know me, I am the maniac of having many response trials, and I want to check fertilization rates with soil test values and all the stuff and look at the yield response so we can calibrate this soil test. That's what we've been doing with phosphorus, potassium, even sulfur with John soil. But with the micronutrients, the problem was, as you saw, that there were no responses. So how in the world we can calibrate a soil test method or a tissue test method when we didn't have a response? So what I decided to do, I put this, and I will have 3 or 4 of these charts. So what I have here is the 4 micronutrients that we work with. And then on the second column is the measured range. That's the ppms in the soil that we measure with those soil test methods. Hot water for boron is the most common, and DTPA for copper, manganese, and zinc. Okay? So those are the ranges. Then the following column is the sufficiency range according to some interpretation of a few states of the north central region, which, as I said before, those come mostly from observations, of the levels that are in good fields. So if we compare the range of values that we measure, this supposedly, quote, sufficiency range in that column, and then with the number of trials where we should expect a response for the low end, okay, and for the high end. This is what we would expect according to those interpretations out there. Well, if we choose the low end, okay, we have a boron deficiency in 1 trial, okay, a manganese deficiency in 1 trial, and a zinc deficiency in 4 trials. Remember, we did not see a response, okay? It's only what we would expect if we follow these sufficiency ranges that are out there. Now, if we use the high end of this sufficiency range, then we have like 80 trials with a boron response. We don't have any for copper or manganese, but we have 65 sites with expected response. See, this is the reason. People out there, they say, oh yeah, in Iowa, half of the corn is, more than half of the corn is deficient in boron. No, it's not. The research doesn't show that. In Missouri, it's the same thing. We could not measure even just one that could be a response, but we didn't show it. Okay, so that's the problem. I mean, people are welcome to use those sufficiency ranges that are out there, but you will make some money from this, sell them. Now, the other thing is the issue of the DTPA and the MELIC3. The DTPA is the method recommended by the NCR 13 for the north central regions with soils like Iowa, Illinois, etc., for copper, manganese, zinc. But many labs are using the MELIC3. Since the MELIC3 came on board about 20 years ago, We did calibration in iron. We have interpretation for the MELIC3 for phosphorus. We have MELIC3 interpretation for potassium, okay, ICP or colorimetric, for phosphorus and for potassium with the moist or the dry test, etc. But we use in all these trials both the MELIC3 and the DTPA, but we didn't see any response. So what we have is this correlation, and others have found the same thing. The MELIC3 is horribly correlated with the DTPA. Okay, the MELIC3 manganese is also horribly correlated with the DTPA. But the zinc, for MELIC3 and DTPA zinc, is relatively well correlated. Okay, so after much discussions here in Iowa State, because many people are using the MELIC3, and some labs or co-ops are recommending micronutrients based on the MELIC3, then I decided to put the MELIC3 for zinc in our interpretations in 1688. It took me strong discussions with my colleagues here because, as I said, we had no response. But everybody agrees that there is a good correlation between the DTPA zinc and the MELIC3 zinc. And so we decided that at least we should put that, because people are using it anyway, okay? But we do not recommend at all the MELIC3 for copper, manganese, or iron. Okay, for the tissue testing, these are the plant parts sampled, and they are exactly the same of a large research that I did with my students years ago for phosphorus and potassium tissue testing. There is a publication, because there for P and K we did find some responses, so we could calibrate tissue testing. That publication is the first one in the history of Iowa with interpretation for P and K tissue testing for corn and soybean. So these are the growth stages that we tried. For corn and soybean at the V5, V6 stage, and then at the R2, R3, or R1 in corn. The testing at R2, R3 and soybean R1 in corn are the traditional that since the 50s. My fertility colleagues have been saying that it's the best to diagnose deficiencies. But the problem with that is it's too late to fix things if there is a problem. So that's why, even though there had been some research, not many, I decided to work with this V5, V6, because at this stage, well, there is a hope that we could do a foliar application or something that, if there is a deficiency, could solve the problem. Now, remember, we didn't have any response, so there's no way we can calibrate this tissue test. The same problem we have with the soil. But in addition to that, what I put in these slides is how the soil tests and the plant tests correlate. And you can see the correlations are horrible. The only cases where there was a significant correlation, but kind of low, was between manganese, plant manganese, and the DTPA manganese, and the leaf manganese with the DTPA manganese. But all the other, there was not. So this is the problem, guys, that we have with the micronutrients. We do not have reliable responses out there that can allow us to have good calibrations in our conditions, not just in Iowa, in the North Central region. So this table, what it shows is the 4 micronutrients that we work on. Then we have a column with a measured range. That's what we measure, the ppms, And I'm showing mainly at the silking stage, okay? Because those were the ones that we could find more data in the literature out there to compare in terms of sufficiency ranges. So, and then we did the same thing. We say, okay, if we would believe these sufficiency ranges that are out there, which I don't trust, by the way, what would have been the expectations of a yield increase? So if we if we use the low end, for example, for boron, we say, okay, the sufficiency range, it has to be at least 4, okay? So in that case, we could have expected a response in one trial, although we didn't, and we could have expected a response to manganese in one trial, which we didn't, okay? And at 6 trials for zinc, which we did. Now, because that's a range, and then you know how people are. You farmers or consultant, we say, well, if there is a range, what do I use? The lower end or the high end? Well, if we have used the high end of those sufficiency ranges, we should have seen a response in all the 24 trials, and we didn't in any. This is what you guys are up against. You look at these sufficiency ranges out there. Where they come from? Where based on response? Do they apply to our conditions? No, they don't. Now this is soybean, okay? That was for corn. Exactly the same thing. We have more trials with soybean tissue testing. We have the micronutrient that we work on, the number of trials, okay? In some trials, we didn't have copper. So that's why we have 46 trials for copper and 58 for zinc, manganese, and boron, okay? Then we have the measured range, what we measure, okay, for plant analysis. Then we have those so-called sufficiency ranges that some people publish and are out there. And then we have this comparison of what would be the expected yield increases based either on the low end of the sufficiency range or the higher end. So if we use the low end, say for example in copper, okay? According to these sufficiency ranges out there, we should have seen a response to copper in 39 of the trials. 0 for boron, 0 for manganese, so maybe they are okay, those lower ends. And zinc, 2 trials, which we didn't see. Okay? But then if we use the higher end, for example, 55 ppm for boron, 30 for copper, 100 for manganese, 50 for zinc, then we would have expected a response in almost all those trials. We didn't saw any. Okay, again, it's up to you. Companies are showing these sufficiency ranges, people out there, you go to the web, to the internet. Okay, it's up to you. In my opinion, you follow these sufficiency ranges with very few exceptions, like this low end for boron and the low end for manganese, maybe zinc. You will be spending money that you don't need. Chances of getting your money back are essentially 0. Now, these results are not just for Iowa. We have a project with several states that we did research, and we found exactly the same lack of response in Illinois, Kansas, Minnesota, northern Missouri, eastern Nebraska, South Dakota, and Wisconsin. We saw some yield responses to some micronutrients, mainly in Indiana and in Michigan. But the soils are completely different. Okay, that's another planet. In sandy soils, of course, beach sands, then we can see a response to various micros. Now, in our sandy soil that we did research in the Muscatine farm, we didn't see a response. Why? Because it still have like 2% organic matter, and of course, it's a sand, it's irrigated, and the irrigation water had micronutrients. Okay. Then in other soils that are not sandy, especially in Indiana, a few in Michigan. Then there was a response to manganese, okay? Again, not in Iowa, not in all our neighboring states. So that work that we did together with several states, we put together about 4 or 5 years ago, this publication. This was funded by the North Central Soybean Research Fund, and we put it, all the states that are there participated, is here in the Iowa State website, is crop 3135. We thought that we were going to do something similar for corn, but we got so discouraged, the probability of micro response for corn is even much less than for soybean. So we never did it. So what did we find in this Iowa research? A lot of trials, foliar, to the soil, band, broadcast, all kind of soil tests and tissue tests. Okay, very unlikely corn and soybean yield response to micronutrients in Iowa. The yield level is not a good indication of the micronutrient fertilization need. Do not apply micros based on removal like we do for P and K. The published sufficiency levels for soil or tissue tests out there are too high, except perhaps, as I mentioned, for the lower boundary of those sufficiency ranges for zinc, copper, and manganese. We can develop reliable interpretations since seldom there is a yield response. And then, although I could not work with that, and I'm retiring, I will not do more work, this use of this OOEDDHA chelate that show potential in Kansas and Minnesota in calcareous soils could be remediate partially, not totally, the iron chlorosis in highly calcareous soils. So what should you do? Okay, I suggest that you use the Iowa guidelines for zinc in corn based on the DTPA or MELIC 3 soil test. But be suspicious of all other sufficient ranges that are used out there. Lime acidic soils, okay, so you don't get the deficiency of something, especially molybdenum for soybean or alfalfa. And watch very sandy or badly eroded soils with very little organic matter. Useful mainly to learn for future years. Okay, if you see a deficiency early, okay, spray as soon as possible. And remember the spot for next year. It's not very likely that you will remediate a micronutrient deficiency by spraying a V5, V6, or things like that, unless even later. But at least you can flag the spot, so then you can do some applications to the soil, pre-plant or something in the next year. Then take both soil and tissue samples, okay, from the bad and the good field areas, okay. Please, even if it's not the right time for soil sampling, take soil samples anyway, because the problem with the tissue samples, tissue analysis, is that there is all this kind of dilution and concentration due to the rainfall, and what causes increases in dry matter or not. So if you take soil sample and tissue sample from the bad and the good areas and are very careful at interpreting the results, that could give you a clue if really there is a deficiency, and what you can do about it in the future, not necessarily in that year. And as I have been saying for 12, 15 years, after all the trials that we have done with sulfur, with Sawyer and I, in corn and also soybean, with sulfur, we have the same problems that for micros. The soil tests for sulfur are a piece of crap. Do not trust them. And the tissue tests for sulfur, the only good are for alfalfa, not for corn or soybean. So if you are going to invest some money just in case to cover your butt, I would invest on sulfur instead of in micronutrients. That's my advice to you guys. And with that, thank you so much. This weird stuff there is finally I came into the 21st century, and then if you scan that thing, should take you to the Soil Fertility website. Thank you.